Hello, class. Reminder that my name is John Bowles, and today we're going to be learning about, from the text, Essentials of Educational Psychology, Big Ideas to Guide Effective Teaching. And the chapter we're going to be looking at is 6.2, and the chapter is called Developmental Processes, okay, from 6.2. We're going to go right into it, and here we go. The big idea. So the big idea that the author from the text is trying to give us, trying to help us learn and understand from 6.2 is cognitive development depends not only on brain maturation but also stimulating physical, social, and cultural experiences. I will repeat: physical, social, and cultural experiences. You're going to need to take a mental note of that or write it down somewhere because these are three really important things that go into brain maturation and on children's natural inclinations as well to organize and try to make sense of those experiences. So this is basically suggesting that the brain continues to develop throughout childhood, adolescence, and adulthood. All three of them, with those three things: physical, social, and culture. All those things are affecting you throughout those life stages. When babies are born, their brains have the basic parts, but aren't finished projects, okay? And stimulating physical, social, and cultural experiences will later help in maturing that brain, right? So when we look at it this way, when we're born, but we aren't exposed to that physical, social, and those cultural experiences. So once we get exposed to those throughout childhood, adolescence, and adulthood, our brain becomes more mature. We understand the world better than we did before. And that is the amazing thing that I loved about this chapter, and I hope you do too. So we're going to go right into it. We're going to go through all the key terms and all the ways that social, cultural, and physical experiences mature the brain. So the first term we're going to look at is synaptogenesis, okay? So this is the formation of synapses, which is the connection between neurons, and this occurs throughout life. So this occurs throughout adolescence, childhood, and adulthood. Myelination, on the other hand, is the formation of myelin. This occurs at birth and peaks at adulthood. So all these three different processes or formation processes are going to be at peaks at other stages, and they're going to affect you throughout life or during childhood, but we'll get into that more. Synaptic pruning is the elimination of unnecessary synapses in order for information to be transmitted efficiently. And this occurs at birth and stops at adolescence. So let's review. So synaptogenesis, right? We talked about how this occurs throughout life, okay? Remember that. This occurs throughout life. For myelination, on the other hand, this occurs at birth, so we get that at the childhood, and then really starts to peak at adulthood. We really get that formation at adulthood. It really starts to kick in for that experience. And then, as for synaptic pruning, okay, this really occurs at birth and stops at adolescence, okay? So we're really getting this mostly at birth. So let's go into plasticity, okay? Plasticity. This is interesting. So this is the ability of the brain to change its structure and function over the course of a lifetime. So this, exactly. So the three terms we just went through, all have to do with plasticity. It's all about the ability of the brain to change its structure and function over the course of the lifetime. So this includes synaptogenesis, synaptic pruning, myelination, are all ways the brain will change its structure and functions over the course of the lifetime. So scheme. So when it comes to scheme is a term put forward by psychologists like Gene Piaget. It refers to cognitive structures, pervasive thought patterns that first appear during childhood, okay, and help children organize knowledge. This in turn helps them learn ways to view, understand, and interpret the world around them, and then to adapt to the demands of that world. Very interesting. Assimilation. Actually, no. I want to kind of give you an example so you better understand scheme. For an example for scheme, for instance, a child that grows up, let's say, in a living home, okay, and in a safe environment, will learn a scheme. Okay, they will learn a scheme living in that lovely home in a safe environment that views the world as just a lovely, just beloved place. Okay, whereas a child that grows up in a violent and unpredictable home will grow up viewing the world as just dangerous place. So that's the way how that scheme experience will affect the way you look at things. A simulation. So a simulation is the cognitive process of fitting new information into existing cognitive schemes, perceptions, and understanding. This means that when you are faced with new information, you make sense of this information by referring to information you already have. So this is information processed and learned previously, and try to fit the new information, right, into the information you already have. A similar process is accommodation. Another one of Pegasus processes, but with accommodation, the information you already have has to be adjusted to incorporate the new information. So it's kind of a battle in like simulation between the simulation and accommodation. So I'm going to kind of go what this basically means, accommodation, so you can better understand the difference between a simulation and accommodation. So accommodation is very similar to a simulation, but it is the cognitive process of revising existing cognitive schemes, perceptions, and understanding so that new information that can be incorporated. In order to make sense of some new information, you actually adjust information you already have, so schemes you already have, etc., to make the room for this new information. This is very related to a simulation, very related. You could pretty much say they're almost about the same thing. It's just there's a couple differences. There are a couple differences that make them separate. But let's go into self-talk. So self-talk refers to the ongoing internal conversation with ourselves, which influence how we feel and behave. So for an example, to help you better understand, let's say you find yourself, I don't know, like in a traffic jam, all right, while rushing to work one morning, okay? You self-talk. Could be pessimistic, and you might think, my whole day is ruined. If I don't get to work on time, I'll never hear the end of it. My boss will think I'm no good and will surely pass me up for that promotion I've been working for all year. You will then start your day in a bad mood and feel demotivated, thinking that there is no point in working hard since you already ruined your chances for a promotion. This is all self-talk in your head. On the other hand, you could have a more positive self-talk, of course. I'll probably be no more than 10 minutes late, you could think. I guess I'll just have to take a quick lunch instead of going out to eat. Maybe if I could turn my report in before the end of the day and make sure that it's error-free, I might still have a chance to get that promotion. And this is the negative and the positive aspects that comes with self-talk. Okay? Now, inner speech is very similar to self-talk. Inner speech has to do with children talk to themselves mentally, okay? This is the key word, mentally rather than out loud. People can no longer hear or see them doing this once they learn how to use inner speech. So they could be self-talking all in their head. They're not voicing it out. That's the biggest thing children need to learn, is how to inner speech. You don't just say everything you think out loud. You don't always want to do that. You want to keep it in your head. People will think you're crazy. Okay, so I think we got a good understanding of those. I want to go into internalization. This refers to the normal process where children learn and absorb, internalize basically, knowledge and rules about the world from social context. This is that social experience I was talking about. Rather than through being specifically told, this is how children learn how to alter their behavior in response to the situation that they are in. Maybe it could be their home, their school, their church, or their playground. So I think so far, if we've taken good notes and we've been following along, I think I've gone through and explained pretty much all the basic concepts of how our brain matures with social, physical, and cultural experience. But I really want to get into this big debate. So equilibrium versus disequilibrium, okay? So first of all, equilibrium. Let's talk about equilibrium. Children that can comfortably address new events using what they've learned previously. That is equilibrium. So you can correctly analyze or address a situation based off prior knowledge that you have, okay? When it comes to disequilibrium, this is when prior skills aren't helpful anymore due to aging and learning new knowledge that can give children a mental discomfort, okay? This can really mentally discomfort them because they're learning all this new knowledge, and it's just not enough. Like that prior skills aren't helpful anymore because all this new knowledge, and then you get a mental discomfort, and then then you go into disequilibrium. You're losing that previous knowledge helping you analyze something that's coming now. Now they call equilibration. Okay, I don't have it listed, but equilibration is when you go from equilibrium, then you go to disequilibrium, and then you come all the way back to equilibrium. So that might just be a total mind twister. So let me just kind of give you an example to help you out. So for example, a child loves the soups that their family eats on a regular basis. Okay, say your mom makes the greatest soup, you eat it all the time. They have developed the schema that all soup is delicious because since your mom makes it, they think it's delicious no matter what. Every soup they're going to have is delicious because my mom makes it, so it tastes good. I don't have any other previous knowledge of anyone else making soup. All I know is that soup tastes like the way my mom makes it, so it's going to taste good. Wrong. The children then has dinner at a friend's house, okay, and is served a bowl of soup, and he hates it. Initially, the child is in the simulation area of equilibration. They feel that since all soup is good, then this soup must be good because previously it was good. They repeatedly keep trying it and disliking it. This leads to disequilibrium that I was talking about earlier, which is a state of cognitive conflict and stress, that mental discomfort. In order to alleviate the disequilibration, the child enters the accommodation phase of equilibration. They adapt their thinking to stop the conflict and realize that now all soup is good and that some of it tastes bad. That's that social, physical, cultural experience that I'm talking about that matures the brain, that develops us. It's fascinating. Okay, so I want to go into this last thing, and this is about zone of proximal development. And this is the last thing the chapter really gets to talk about. I think there's more important topics, but this is very important as well, so I really want to address it. So, zone of proximal development is the range of tasks that are too difficult for a person to learn alone, but can be learned with guidance from someone with experience in the task. This term was developed, I can't even say his name, Vygotsky, as part of his theory on child development. I think I got that right. The zone has a lower limit, things that are difficult but possible for a child to learn alone, and an upper limit, things that a child cannot yet learn even with assistance from an adult. For a toddler, an example of the lower limit might be putting shaped pegs into similarly shaped holes. An example of the upper limit might be adding and subtracting two-digit numbers. Let me repeat that again. For a toddler, an example of the lower limit might be putting shaped pegs into similar shaped holes. Very simple thing to do. An example of the upper limit, okay, more advanced, might be adding and subtracting two-digit numbers. That's more complex. That's that zone of proximal development based off of physical, social, and cultural experiences. Let's remember that. So I hope you learned a lot from this lecture. I hope you really took thorough notes. You listened to that. The biggest three things you need to take out of this whole thing is the big idea about the brain maturing based off of social, culture, and physical experiences. Thank you and have a great day. My name is John Bowles. See you later.